Okay, hello guys. It's a beautiful morning. I'm coming today with the concept of oxidizing agent and reducing agent. If you have not watched my previous video, please check under my profile. You will watch the previous video on oxidation and reduction. I explained oxidation and reduction, but remember, redox reaction, redox reaction is a reaction in which oxidation and reduction takes place simultaneously. Most textbook they use the word simultaneously is already confusing learners. Simultaneously in this case means the same time. It means if oxidation is taking place, reduction is taking place the same time. That's the meaning of simultaneously. So we'll avoid confusing words here just to prove to you that we can speak English. No, we are refraining ourselves from that. Oxidation and reduction, we say, and redox reaction, we say oxidation and reduction are taking place the same time. Now I want to look at the concept of oxidizing agent and reducing agent. Now, remember, if oxidation and reduction is taking place at the same time, we call it redox reaction. If you want to understand oxidizing agent and reducing agent, look at it in two ways. Because I'm doing something to you, you must also be doing something to me. What I'm doing to you, I will be called that thing. And what you are doing to me, you will be called that thing. So, if I am making you, like take a reaction of this nature, if this is tin reacting with nitric acid to give you tin oxide plus nitrogen oxide and water. Now let's look at the reactants, which is the left hand side of our reaction. One of them is being oxidized and one of them is being reduced. We will use that notion of oxidation. When we get to oxidation, we will use who is an oxidizing agent and who is a reducing agent. And remember, if you want to pick your answers, it must, for oxidizing and reducing agent, it must come from the reactant side. Okay, let's look at this clearly. Tin, we have a law in chemistry which says any element that is not combined and is not charged, the oxidation number for that element is 0. So tin is just not charged, it's not combined. So the oxidation number state of tin here is 0. So you see here, the product forms tin oxide. Are you seeing? The product forms tin oxide. So we have to look for the oxidation state of tin here as a product. Now we are looking for the oxidation state of tin because we don't know it. We assume that it is what? X from this formula. We say it is X. Another rule says any compound that contains oxygen, the oxidation number of oxygen is already 2. So it's generally given like that. So the oxidation state of oxygen here is 2. How many atoms of oxygen are there? 2. So it's X plus, it's minus 2, not 2. Minus 2. X plus 2 times negative 2. This negative 2 is a rule which says that any compound that contains oxygen, the oxidation state of oxygen is already known to be what? Minus 2. So we have X plus, this time this will give me negative 4. Now, the sum of oxidation state of a compound, why do we call this a compound? Because it's tin oxide, it's a compound. The sum of oxidation state of a compound is equal to the overall charge. This one element is not charged, so the overall charge here is 0. It's equal to 0. So we are looking for tin X. Remember, our X stands for tin. X will be equal to, you carry this one this side, it gives you plus 4. So tin has left from 0 to plus 4 in tin oxide. So tin has left from 0 to plus 4. Are you seeing? So 0 and plus 4, who is bigger? Plus 4. So tin has left from a smaller number to a bigger number. It means it has been oxidized. Now, when you look at nitrogen, let's look at nitrogen in this case. Let's look at the oxidation state of nitrogen in this case. Now, this is a compound. The sum of oxidation state of an element will be equal to the overall charge. So, another rule again, any compound that contains a group 1, the oxidation number of that compound is 1. Now it's oxygen. We've been told that any compound with oxygen, the oxidation state is minus 2. So we already know this. The one we don't know is this one. So it's our X here. Okay, so we have this times this will give me 4 times. We already know this one to be 1 plus 4x, because we are looking for this. Remember, this 4 stands for everything. plus this, and it will be 3, it will be 4 times this, which give me 12. 4 times this give me 12, times the oxidation state of element is -2 times -2. It will be equal to the overall charge. The overall charge here is 0. So this times this is 4 plus 4x. This times this give me -24. -24 equals to overall charge here is 0. Are we there? We carry this one is a number, all numbers this side. Numbers and letters stays on the left. We are looking for x. So it will be 4x because this plus here becomes what? Positive 24. This goes this side becomes minus 20. So 4x is equals to 24 minus this give me 20. X will be equals to 20 on 4, which give me x, which means equals to 5 plus 5. So now the oxidation number of tin here of nitrogen here is plus 5. Of nitrogen, this one is plus 5. Let's calculate the oxidation state of nitrogen in this product. Let us see whether it has been reduced. So if you come this side, this time this will give me 4x because we are looking for x, plus this time this give me 8. Then any element that contains oxygen, the oxidation state of oxygen is -2. It gives me this. We already know this one. The overall charge here is not charged, so it's equals to 0. So 4x will be equals this time this give me -16 equals to 0. 4x will be equals to, you take this one this side becomes 16. Now we divide both sides by what? We divide both sides by 4. We divide both sides by 4. X will be equals to 16 divided by 4. It's 4, right? Plus 4. So now let's look at what has happened here. So the oxidation state of tin here, of nitrogen here, is plus 4. So nitrogen has moved from plus 5 to plus 4. It has been reduced from a bigger number to a smaller number. So it has been reduced. Now, if you look nicely, we have proven to you that a redox reaction has also already taken place. Tin moved from 0, tin here is plus 4. Nitrogen moved from plus 5 to plus 4. From this to this, small number to big number, oxidize. Big number to small number, reduced. So you see that redox reaction has taken place. Oxidation and reduction has taken place at the same time. But now our focus here is the concept of oxidizing agent and reducing agent. Who is the oxidizing agent here? Who is the reducing agent? Take a look at this. Nitric acid, because tin supply this guy with electron, because nitric acid accepted the electron, it caused this guy to be oxidized. So this one, because it accepts the electron, this one is the reducing agent. This nitric acid is the oxidizing agent, not reducing agent, please. Listen again nicely. Because this guy supplied this guy with electron, because nitric acid accepted it, so the two things have happened. I have supplied you, and because you accepted. Are we looking at it that way? This guy supplied this guy with electron. If this guy didn't accept it, then nothing would have happened. But this guy supplied this guy with electron. Because this nitric acid accepted the electron, something happened to it. And because you gave nitric acid something happened to nitric acid. So redox reaction has already taken place. But let's come nicely and see oxidizing agent and reducing agent. What is the result of tin giving you electron and you accepting it? Nitric acid accepted the electron. It makes things to become what? Oxidized. So nitric acid is the oxidizing agent, because in the course of accepting the electron, this guy becomes oxidized. So nitric acid is the oxidizing agent. You think because you gave this guy electron, you did something to him, to nitric acid. Nitric acid now, nitrogen in nitric acid becomes reduced from +5 to +4. So this thing is the reducing agent. Reducing agent. This one is the oxidizing agent. One more time again before we close the video. I want to revise it. Two things are happening here. I am giving you. If I give you, you don't accept, nothing will happen. But as I'm giving you, because you are accepting, you are doing something to me. When I'm giving you, what am I doing to you? I am reducing you. Giving you electrons here. Tin reduce nitrogen in nitric acid. So tin is a reducing agent. What did tin do to nitric acid by giving it electron? It reduces nitrogen in nitric acid. So tin is a reducing agent. Because nitric acid accepted it, what happened to tin? Tin was oxidized. So nitric acid is the